What's up, guys? How's it going? So, completed the first heat treat ever in my life. That was fucking crazy. So yeah, learned a lot of things and gonna change a lot of things going forward. So, if you didn't see all the Instagram stuff, basically what happened was I did K390. I went a pre-soak of 1500 degrees, 10 minutes, and then ramped up to 2150 and held there for, or I'm sorry, the 1500 was 10 minutes. I said that, okay. And then the final soak was 2150, 15 minutes. And what happened was I used this coating. So you saw, or I can show a picture if I have one, this Ceram guard. It goes on, it's like a ceramic coating basically, like for protecting steel. And then when it goes in the oven, it heats up and it bakes and it turns red. You can see on the inside too, I don't know if you can see that, but basically that black spot is where decarb happened. So what happened was the knife expanded due to thermal expansion, and I didn't account for that. And so this Ceram guard kind of cracked and allowed air to get in, and oxygen and carbon form oxidation, which is a decarb. And it's very, very detrimental to especially knives because they're so thin, but also carbon is actually what helps achieve hardness. So if you austinize at a higher temperature, you have more carbon in solution. Thus, when you quench, you trap all that carbon and create hard martensite, in a nutshell. Other things happen, but in a nutshell. And so that's what happened. Thermal expansion, cracked open, air was allowed to get in. My plate quench probably could have been, I probably could have like clamped this down a little bit harder, but again, first time. And so when I took it all out of that Ceram guard, I used a wire brush, got it all off, got it down to, it was like 100 and probably 50 degrees. I held it in a glove and then ran it downstairs, did a quick HRC test, and it's super soft, obviously because of all that fucking decarb. So I cryoed both knives and then tempered. And then after the first temper, I did a 925. Oops, excuse me, 925 for 1 hour. And the reason why I didn't do 2 hours was because I just wanted to get that, I wanted to get that temper set after getting rid of that retained austenite through the cryo. And then after that temper, I kind of ground off the decarb of one knife. Or actually, this knife that I'm going to show you. Ground all the decarb off, tested it again. So it was at 62 before, I got a spot on there. It was at 62, went up to like 63. 62, 63 after the cryo and the temper. And then did a second temper at 925 for 2 hours and got all the decarb off. And then you guys saw in my Instagram post, and I'll post a picture of it, it was at 62. Roughly between 63 and 62. I'm going to call it within the 62 range. So I was a little bit disappointed with that. So what happened is after that I ground it a little further, and I noticed that there were these sort of like pitting or inclusions or whatever. Not inclusions, more pitting. So I ground all that out. Finally got down to like just clean metal. And I tested it one more time. And I did, I think, 3 tests. And each time it came up dead nut 63. 63 HRC K390. So, this knife right here, I threw some quick scales on it. 63 HRC. As you saw in the video, I snapped the other knife in half just to check the grain. Typically with ingot steels, you can tell if the grain is grown or not. You can visibly see it. With powder metal steels, it's very, very difficult. the grain is not so much or in powder metal steels, it's more getting the carbides smaller than the grain. But with this steel, I snapped it. I couldn't visibly see any grains. Where are the fucking pieces at? Oh, they're inside, I think. Oh no, they're right here. So I couldn't visibly see any grain growth as far as like over bringing the temperature up too high. Because remember that temperature is a larger factor in growing grains than time. We can hold certain steels at 30 minutes at 1900 or 1975 and not get significant grain growth, if any. And let's see if I can find a good one. These, I mean, they're pretty, it's silky kind of, like it's silky smooth kind of. I don't know if you can see that. I'm gonna assume you can't. I'll try to get, better pictures and put it up. So that's why I broke the knife, because I wanted to check. I wanted to make sure, like, I'm not soft because of, a ton of retained austenite or grain growth or anything like that. I think what happened is that thermal expansion, I got decarb, and at that high temperature, that decarb happens at a more rapid rate, and I lost so much carbon that when I quenched, there wasn't enough carbon in there to make it, because typically you want to be 63, 64 when you're quenching this steel to get that high hardness, and I just wasn't there. So with that carbon loss. So that's what happened with that. But I do have this knife at 63 HRC, a solid 63 HRC. And so I'm going to test it. I did sharpen it on DMT Coarse, DMT Fine. I did 4 sharpenings, so they did 1 right before I came out. We are at 11 thousandths behind the edge. It's a very thin knife. The stock thickness is about, I think 93 thousandths total stock thickness. So it's a very thin knife. I did do a little, and I'll show the clip, is I did try to do a little ductility test. It's pretty solid. It's like it bends and can give. It's a very solid knife for how thin it is. So I mean, again, like that goes to show that I didn't really disrupt any of that grain structure and weaken the steel. I merely just lost a ton of carbon and suffered a lower hardness. So I think the next run of K390, because obviously this is going to be my first test, and there's already people hitting me up for some of these knives. I ordered a bunch of K390, trust me. A 23 by 6 inches of K390. We got a lot of K390 coming. I'm going to run at least 4 more tests on little coupons, get my curves down, and then get these to where I want them at that 65, 66 range. So I know it's possible, but that's what we'll do. That should be next week. But right now we're gonna do a rope cut test, and then I'm gonna do a little bit of a toughness test. So I got the Bacote wood. I'm gonna slam on that for a little bit, and then I got some brass, and we're gonna see what we can do to this edge. I feel confident it's gonna perform very well at 63. Even the Spyderco K390 is coming in at 63, or the higher end is 63, and it sharpens like a dream. And this sharpened just as similar. If anyone wants to test this, like, hit me up. It's 63 Rockwell, so it is what it is. But I got a nice grind on it. Everything's even. If anyone wants to test it to sharpen it, whatever, hit me up. But this is going to be a shop knife, so I'm going to keep it in here in the shop and cut pouches open with it and all that shit. So it's going to be a good knife. So yeah, let's run the test. That's where we're at with this. I'm going to get that fucking 65, 66 nail and get people knives. Yeah, so yeah, fucking excited about it. Also, if anyone thinks that heat treating is super, super easy and has never done it before, fuck you. Because it's very, very difficult. Guys like Roman and Triple B and anyone else who's in the game fucking heat treating super steels, or any steels for that matter. Even 1095. Actually, 1095 is a very, very, very hard steel to heat treat. Contrary to popular belief, because you need to do a bunch of normalizing cycles, make sure you get the grain. Anyway, all those guys spend a lot of time heat treating and coming up with their own protocols and stuff like that. So just a reminder that they are actually, like, you know, when their knives are a certain price, you just have to take into consideration that they're offering you all of these different steels, and they have to go through this every single time. And I mean, I'm sure they have their process down now where they don't really have to, you know, do a ton of testing or have a lot of failures, but I'm sure when they started out, they did. So I just want people to learn from my mistakes, and I will learn from everyone else's successes or mistakes. So that's where this is kind of heading. Again, still going to do testing against customs and production now that we have, because this knife right here is the same Rockwell as this, so we'll get our results after. I know that's going to perform better than this because it's thinner behind the edge, regardless of what people think about behind the edge thickness. It does apply to things like rope and stuff like that, where you're binding up. Cardboard, not so much, because you don't really bind up on cardboard. But I digress. Let's get to the test. Rope, and then do some other shit, and then talk about it. So that's where we're at. Guys, what's up? So we ran the test, did the rope cut test, K390 Shark, 63 HRC, 10 thousandths behind the edge, 30 to 35 degree inclusive on that angle. We did 360 cuts, which, if you can look back on the previous episodes, it's the same as Maximum. Now I know. That's outrageous! Oh, K390 couldn't beat Max, man. Did. And we know this because I know that Maximum has harder carbides, or more harder carbides rather than K390. I also know that this isn't the same HRC as Maximum. It's 63 Rockwell. The Maximum that we tested was 66? No, 68. Sorry, 2 points above that. Also know that Maximum was a thick 21 thousandths behind the edge. 21 thousandths behind the edge. And we also know other things like, hardness hardness is the top dog as far as edge retention. We know this from that K390 study that was done on M4. Reading about that. Basically, they took M4, different Rockwells. The lower Rockwells had more carbide volume. The higher Rockwells had less carbide volume, and the higher Rockwells outperformed in the K390 cut test. We all know that. Again, all of these things culminate into one thing, and that is geometry. Geometry will always do the cutting for you. And I'm not saying that hardness doesn't matter. Hardness is that next step, along with composition, where geometry will do the cutting and hardness and composition will dictate how long or how far. How long and how far. 360 cuts is really good for 63 Rockwell K390. It's better than the production. We know this. It's better than that production 10V. It's the same as the Maximate production. If I reground that Maximate, which I will at some point, down to this 10 thousandths behind the edge, it will significantly outperform everything else. I promise you, it will. All of the testing that I've done proves that. And I understand that it is the material that I'm cutting through, but you are going to get a performance increase with a regrind. You are going to get a performance increase with thinner geometry. We can go even thinner. I wouldn't go any thinner on this one only because the hardness is at 63. We could. It could still probably be stable at a lower geometry, but I would like to have a harder geometry to support, or I mean a harder material to support that geometry. So, with that said, this is where we're at with that edge. I left it taped so we can mark it. I mean, that edge is pretty, if you all want to agree, I mean, fairly toasted. So, we'll remove the tape and we'll do a little edge testing with the brass and the Bacote, and we'll really get in there and try to see if we can get some deformation and stuff like that. Like I said, I pressed down on this and we got some ductile feedback. It's pretty bendy. When I broke that knife, that was after the first temper. I was at a good 75 to 80 degrees before that snap, so that gives you an idea. So, Bacote is supposed to mimic like some sort of bone, and we can get right in there. Nothing yet, but I mean, there's nothing. And you heard, that sounded pretty fucking terrifying. And if there's any other tests you guys want me to do, like, I mean, I know zip ties is a big thing or whatever, but I think Bacote is a good test, like, very hard wood. Let's really get in there. I mean, we got some, but I mean, it's still, it's still cutting that paper nicely. So, I mean, we could keep going, but we're not gonna, I don't think we're gonna do much damage to this edge. Nope. So there's the Bacote, and I mean, we'll do the brass rod like everyone does, and kind of just get in there. Getting some chipping at the back end here. I can see it visibly. We got some rolls in the front. So, I mean, we're getting some deformation in the edge on brass, and I pretty much knew that was going to happen. And I'll get a zoom shot of all this stuff, but here it is with the paper test. Like, we can still cut the paper, which is, I'm pretty impressed by. But that's that thin geometry. Like, it's basically a saw now. And I mean, we would have to go out to the diamond to get this out, but if you were in the field or something like that, or at home or wherever, it's just that the geometry. All right, now it's just pulling at that spot in the back. But it still cuts right at that spot, which is, and I could feel like a burr. But I mean, this is impressive stuff. This is 10 thousandths behind the edge too. So I mean, I would feel super comfortable doing it with a Spyderco PM2, no problem. Like, that edge is very, very thick. 10 thousandths is like, I mean 11 thousandths, sorry, it's 11 thousandths behind the edge. 11 thousandths to 10 thousandths is like chef knife territory. Some chef knives go thinner than that, but that's getting into chef knife territory, and there's not a lot of people that would do this with a chef's knife. And I mean, this is more than you're ever gonna do to a blade. Ever. So we can go a step further if you want. I'll just smash this knife into this piece of oak as well. I mean, no. Like, you want to see torture? Let's do torture. You know? Like, obviously there's going to be a ton of damage on the edge after that, but we can still get, you know, cuts up front. I mean, the geometry on this is insane. And I mean, for the loss of carbon that we got and the loss of hardness that we got, yeah, like, that's a thick piece of oak. That's solid fucking oak. I think that this first time heat treat on this knife the first time I've ever done is a success in my book. So this is a success. But yeah, it's gonna be a nice shop knife. And like I said, I'll have more K390 this week. And testing, and then I'll try to crank the hardness up on that the best I can. 65 to 66. And we'll have some sharks ready for the world. The Rex 121 is still out. I'm also going to be doing Rex 121 coupons next week when my foil gets here. When I ordered my oven, it was taking so long that USA Knife Maker, shout out to them, gave me a $50 gift card, and I was like, hey, just send me foil, is that cool? And they're like, yeah. So I'm going to get some foil. I'm probably going to end up buying more foil just to have around, so. And then primarily use the oil for our 01 for this design that I have. It's a little 7 inch, I think it's like a 7 or it's an 8 inch kind of like hunter Skinner type thing. It's gonna be an 01 tool steel. I'm gonna try to also find some like, I don't know, I just want like older tool steels for that one. Just kind of, it's like, it's called the old man, so, or the old timer. So, but yeah, that's the torture test of this 63 Rockwell K390. It performed as well as Maximate production, blew away the production K390 that we had. So it is, I don't know. Fucking thumbs down. Come on, thumbs down, bitch. Let's go. Thumbs down. I'm just kidding. Thumbs up. You know, subscribe to my channel. Subscribe to all the guys that are out there that are doing all this shit. I'm just a fucking cog in the wheel. That's it. If you guys want me to test anything, let me know. I'm going to primarily focus on K390 for right now just because I want to nail it, and then we will dive into the other steels. It's just some advice that I got, and it's very sound advice, and I don't want to go broke doing this hobby. Honestly, I'm selling these knives to, you know, just recoup and buy more steel to test. So like, I'm not trying to live high off the hog, if you will, from this. Someday, but not right now. Maybe when I retire. But yeah, thanks for watching. Subscribe, all that shit. Thanks, guys.